What we're going to do now is we're going to have Henri. Henri is the CEO, CTO of Streamr. One of my favorite projects, known them for a while. Going to kind of help them to kind of build the developer community. Kind of background is that Henri spent many years working with algo trading systems, fairly technical, but now he's doing both sides, CEO as well as the CTO of the company. So without further ado, I'll introduce you to Henri, guys. Please welcome him. Thank you.
Thank you, thank you. Can you hear me via this mic over here? I guess you can, right? Excellent. Good. Let me just check this. Yep. Good. Good to go. So, hi, I'm Henri Pihkala, CEO and founder at Streamr. Thank you. Huge thanks, Antonio, for inviting me over. Excellent to be here, and thank you all for coming. Maybe a little bit about me. I have a software engineer background. I've been working with real-time data for more than the past 10 years, first in algorithmic trading, building infrastructure and tools for that. Then I went on to start Streamr, and that was back in 2014. The first generation version of Streamr was a cloud platform for a broad range of use cases, not only finance, but also IoT, social media, online advertising, smart cities, you name it. And around 2 years ago or so, our team kind of saw the light, and we realized that with our background and our expertise, we have a fair chance to contribute to the decentralization of applications and unlock new patterns for data monetization, data ownership. So we set a plan in motion to build a decentralized version of the Streamr platform. So this presentation is about that journey. Okay, so we're using the centralized cloud version as a starting point, and we're working towards decentralization incrementally. And this allows us to maintain a working product at all times. Some projects, you know, they raise money, then they disappear underground for a number of years to hack away, and then maybe they emerge eventually with a beautiful, decentralized, great solution, or not. And that's okay. But we chose to have those centralized training wheels, if you will, to allow our community to ride the bike earlier, immediately, in fact. So, to kick off this talk, I'll briefly explain what Streamr is and intends to be. I'll explain what major components Streamr consists of. Then, we're going to drill down into those components. We'll talk about hybrid applications with both centralized and decentralized functionality, and use the Streamr marketplace as an example of that. Then we'll dive into the challenges of decentralizing the Streamr network and discuss topics like identity and authentication, data security, sharding, scalability, stuff like that. Okay? Let's go. So just to brief you in on what Streamr is about. So we're building a decentralized real-time data economy. And as an example use case, let's consider a connected car. Now, while the car is driving around, it needs data from other systems, other machines, such as traffic congestion information from other cars, availability of charging stations nearby, weather forecasts, and so on. Now, Streamr provides a single interface for the data consumer, the car, to go in and subscribe to the data streams it needs, as well as pay for them using a cryptographic token called the Streamr data coin, which is an ERC20 token on the Ethereum blockchain. Now, obviously, the car is a data consumer, but it's also a data producer. So it can go and make available the data that it's producing For example, measure cell tower signal strength, which is data that's interesting to network operators. Measure road conditions, which is data that's interesting to the road authorities or smart cities. Maybe share the location or passenger hunger level to nearby advertisers, and so on. So no more setting up APIs, servers, credit card payments. Machines don't have credit cards, right? By eliminating the friction and middleman from data delivery and associated payment, we allow a real-time data economy to emerge. So the Streamr platform consists of three major components. There's the infrastructure layer, which is the network. That's responsible for data delivery, messaging, as well as storage. Then there's the marketplace over here. It's like the eBay for real-time data streams, right? Anyone can go in there and make available some data that they're producing, either for free or for payment. So it kind of promotes data sharing, data discovery, data monetization. And then we have the Streamr engine, which is for analytics. It's for building processes that react to incoming data, apply some computation, and produce some kind of output for that. Now, in this talk, we're going to briefly look under the hood of the marketplace, but mainly focus then on the Streamr network component over here. Decentralization of the engine is too large a topic to fit into this 30-minute talk, but if you're interested in that specifically, you'll find information online about how we, for example, collaborate with the Golem project to figure that out. Cool. So as a little appetizer, before we dive into the main course, which is the Streamr network, let's look at the upcoming marketplace. Now, the first version won't be fully decentralized. Instead, it will be a blockchain-enabled kind of hybrid application. So what does the marketplace look like? It's a view into the publicly available content on the Streamr network. So there's a browse view with the data products shown as these nice little tiles here, along with search and filtering functionality and so on. The products can be free, and they can be available for a license payment. You can drill down into a product to see its content. A product can bundle a number of individual data streams. There's a real-time preview of the data available here, and the product owner can set up these nice visualizations for the product and so on. For paid data, there's a purchase button. When you click that, it starts the purchase flow. It uses a Web3-enabled browser, such as MetaMask, Mist, or the Brave browser, to interact with the marketplace smart contract. Now, there are some usability annoyances, such as needing to grant allowance in order to transfer tokens via the smart contract. But generally, the flow is pretty okay already. And with new token standards, it can be made smoother in the future. So the first marketplace version will be a hybrid app, partially centralized, kind of like CryptoKitties. How many of you have played CryptoKitties? A few. Good. That's a dApp for breeding and trading digital cats. Okay? The cat's genes, cat ownership, and the reproduction algorithm are on the blockchain in a smart contract. But the interpretation of the genes, for example, like generating the cat's picture and the cat's traits, they are done off-chain. And in applications where the user experience is key, such as CryptoKitties, or we think the Streamr marketplace, having off-chain functionality on the side to support usability is still required today. In our case, we store on-chain critical information about products, beneficiaries, licenses, subscriptions, payments. And off-chain, we have product metadata, all content like product descriptions, product images, the data, obviously, itself on the Streamr network. The marketplace uses a centralized backend for caching and augmenting the data that's on the blockchain and uses it for searching and filtering. And these are features which smart contracts aren't very suitable for. Now, here's a cool thing. So by gaining insight into what to put on the blockchain and what to keep off-chain and learning to make those two work together, we've been making excellent progress with the marketplace. Initially, the first version was planned to be available by the end of this year, but actually, I have an announcement to make. We'll be able to launch it way ahead of schedule by the end of Q2 this year. Yeah. Thank you very much. Anyway, next we'll take a good look at the Streamr network and the challenges that offers. So going deeper. The job of the network is to deliver messages from data sources to data subscribers. So we're talking about a massively scalable publish-subscribe pattern here. Applications connect to the network to send and receive data. Applications include, of course, the Streamr marketplace and the engine, but any of your applications can connect to the network as well via the APIs. Also provided by the network is data storage. The history of data typically has a value of its own as well. And the network should give some guarantees about data security, for example, prevent unauthorized access to data. So let's look at the starting point, the centralized network implementation that we have going in there. So as you can see, there's a number of components participating in the overall data pipeline. There are open source frameworks. There's Apache Kafka, which is like a distributed event log or message queue, if you will. There's Zookeeper, which is a consistent key value store, which Kafka uses for cluster coordination. There's Apache Cassandra, which is a NoSQL database. There's Redis, which is an in-memory key value store, which also has this pub/sub thing going on. So a data source, such as a sensor, it connects to the API and produces a data point, and that data point travels through this pipeline and gets pushed to all the subscribers on the other end. Now, this works, this scales, but all the ready-made components here are designed to run on trusted servers and trusted networks, right? So all of this needs to go. All of this needs to be replaced with something else. But we're going to come back to Kafka and Zookeeper a little bit to steal a few good ideas for our decentralized network. So let's see. Now, skipping to the other end, the goal decentralized network, and let's make some notes on what questions we need to answer on the way from A to B, right? So this future version will be a peer-to-peer network. A data source should be able to connect to any of the nodes in the network, produce a data point to an API similar to what we have on the centralized version, and have the message delivered via the network to all the valid subscribers, which could be connected to any of the other nodes in the network. Now, already questions raised here. Peer-to-peer networking, things like peer discovery, routing, NAT traversal. Then we have questions about identity, authentication, data security. The data is traveling via untrusted nodes here, and a question about storage. So we'll come back to those topics, but first let's explore a few more angles and raise even more questions. So the idea is not to build yet another blockchain, but rather build a decentralized network for real-time data delivery. So it's a companion network to a smart contract platform, or a smart contract blockchain. Today we use Ethereum, but something else would work just as well, and the idea is to include others in the future. The data traffic obviously never touches the blockchain. The network can use the blockchain on the side for certain functionalities such as payments, staking, identity, access control, network coordination, and so on, as we'll soon find out. A question raised on this slide is about blockchain scalability, right? How to design the Streamr network in such a way that the current day limitations of Ethereum don't mess it up or don't limit its scalability. The Streamr network needs to scale to millions of data points per second. And for this, we need a clever sharding scheme within the Streamr network. So the network is divided into partitions, and a group of nodes is responsible for each partition. So when a new data point enters the network, we need to find out which partition it belongs to and which nodes are responsible for that partition. Now, questions raised here are about the network control, right? Partition assignment to nodes may be guided by a reputation system, plus how to assign the data point to partitions. So we'll get back to that. Last question slide, I promise. To achieve decentralization, anyone needs to be able to run a node in the network and earn data coin in exchange for the bandwidth and storage that they are contributing to the Streamr network. So running nodes in the network should be attractive to anyone with that kind of idle capacity. So correct behavior should be incentivized and misbehavior should be punished. Now, the questions raised here are, how does the incentivization system work? How can the nodes deliver proofs that they are doing the right thing? And how to make sure that the network can operate in adversarial conditions? Okay, a lot of questions. Here's a summary of the topics we raised, questions we raised by looking at the network from these different angles. Now, the key thing to realize here is that many of these problems can be addressed independently of the others, meaning that, again, there's an opportunity for incremental development instead of aiming for an all-or-nothing release. Now, we're not going to go into all these topics today, but I'll highlight some of them now and leave the rest for Q&A or beers afterwards or whatever. Also, you could check our white paper for more detailed answers on all these topics. Cool. So let's go to identity and authentication. Now, as you know, centralized apps typically use a username and password combination to authenticate a user by comparing given credentials to correct credentials stored in a database, right? But on blockchains, on the other hand, your private key is your identity. And using basic cryptography, it's easy to verify that a digital signature was done using a particular private key. Now, there's no reason why hybrid apps couldn't use both approaches in parallel as an intermediate stage. For example, this is our future login screen, which will be deployed as part of the rebranding that's going on. So we have a traditional login window, but we also have this sign in with Ethereum button over there. So what that does is that it makes you sign a random chunk of bytes, a login challenge with your wallet, and then it can send the signature to the back end, which can verify that, okay, this guy is certainly in possession of the private key for this account. And if that account is bound to their centralized Streamr account, then they know that they can log that guy in and let him in. So, of course, eventually the username password combination needs to be dropped, right, completely. In a decentralized version, we don't have a centralized database of credentials to compare a login attempt against. Cool. Data security. Now, since we have a robust cryptographic identity in the private key, wouldn't it be ideal to establish data security around the same mechanism, right? So in the network, the data travels through untrusted nodes. To prevent tampering of the data and to prove origin of the data needs to be signed, right? Just like the login challenge. So we can use the same identity, the same private key to sign data payloads, which is cool. The same public and private key pair can be used for encryption as well. The pub/sub use case we have going on, that needs broadcast encryption, which is a kind of complicated topic. But basically we can have, for example, shared key-based encryption for the data payloads and delivery of those shared keys happening by encrypting them for each valid recipient, so that those recipients can decrypt the shared key with their private key, right? I guess the takeaway here is that simply by having an Ethereum private key, you can not only interact with Ethereum, but you can also send and receive data on the Streamr network. Okay, another topic, network coordination. Now, let's go back to steal a few ideas from the centralized version and examine how Kafka uses Zookeeper for cluster coordination. Now, Zookeeper is a consistent key value store, which Kafka uses as a single source of truth about the cluster state. It's being used for node discovery, partition assignment, leader election, and a few other things. Now, okay, having a single source of truth means that the nodes don't need to form consensus in a peer-to-peer fashion, making the network coordination much easier. I wish we had something like that in the Streamr peer-to-peer network. So in the case of the Streamr node, where could we look for reliable information, reliable metadata about the network? A Zookeeper wouldn't work in a trustless environment, for sure. We need something which can execute our network coordination algorithm in a trustless and decentralized way. Oh, but we have the companion smart contract platform, right? We can use that as a single but decentralized source of truth. Actually, a smart contract is a perfect way to deploy a decentralized algorithm to coordinate the responsibilities in the network. The only problem is reads are fast, but writes are expensive, right? So the first versions of the network coordination algorithms need to be simple enough to work within the limits of current-day Ethereum. But of course, more elaborate versions can be made a bit later on. Cool. About sharding. With that network coordination algorithm, we now have a way to assign partitions to network nodes. But what about assigning data points to partitions? Well, this needs to be a fast and unquestionable operation due to the high volume of data that we're targeting. So actually best if it can be done locally without consulting the network at all. So let's see. There's a way, which is, again, a bit similar to how Kafka actually does it. So when the Streamr node gets a new data point from a connected source, such as a sensor, it can hash the stream ID and modulo that by the number of partitions, P, in the network to locally calculate a partition number. Now, that's the partition number that the data point belongs to. And the node, it can discover P as well as the mapping from partitions to nodes from the smart contract, the single source of truth, and relay the data point to the correct nodes in the network, which is what it's supposed to be doing. Now, this forms a kind of DAG, or directed acyclic graph structure, for the data flow in the network. Maybe it's worth noting here that no information gets written to the blockchain in the course of data delivery. Sure, the nodes need to register with the coordinator smart contract, but the set of nodes is kind of small and stable compared to the high volume data production going on. So on our roadmap for the network, the implementations will evolve from the cloud starting point to a peer-to-peer version featuring partial solutions to the mentioned problems. Now, these intermediate versions will still run on a trusted network, but they will incrementally keep getting closer and closer to the finished trustless version, which will eventually take over. The cool thing is that applications using the network can stay pretty much the same over different milestones of the network, making the lives of data producers and application developers much easier. Perhaps a little summary of key things we try to keep in mind while thinking about incremental decentralization. Try and solve independent sub-problems. Release those solutions as hybrid versions as you go. Try not to reinvent the wheel, but instead build on existing wheels and try to invent the car, right? If you like what we're doing, come find us online, streamr.com. We're on Twitter as Streamr Inc., Telegram as Streamr Data, and on Reddit as r/Streamr. We make your streams come true. Thank you very much.
Thank you very much, Henri.
Thank you.
A very good project, and congratulations on bringing the go-live date forward. So it's good to see a company that's actually shipping a lot of code rather than just onboarding partners that we see in this space. Congratulations.
Oh, we're onboarding partners as well.
You are too. You're actually shipping code, which is the key. So without further ado, introduce yourself, Mustafa.
I think you introduced me earlier, but I guess I can introduce myself again. So yeah, I'm a PhD student at University College London, part of the Information Security Research Group, and I'm going to be presenting here as well after this Q&A about a project, one of our projects that we're doing at UCL. I've led the Q&A sessions here at this meetup for the past few meetups. So I always kind of like to ask interesting and challenging questions. So I might play devil's advocate to make things interesting. And but I want to kick things off with one question and then leave it to the audience. So yeah, are you going to hand the mics around? Okay. So to kick things off, I guess, in what way does Streamr compare to oracles? Because one of the things that I would ask for any decentralized system is to what degree is it trustless? So one of the things with oracles, for example, or any problem, or with any kind of solution that attempts to get real-world data on the blockchain, is how do you verify that data is actually authentic? Yes. How do you prevent, for example, people pretending to be cars and pretending to have data streams when they're actually fake data streams?
Sure. Good. Okay. I think this works.
Sure.
That's fine.
Yeah.
Okay, so if you think about oracles, that term is usually used when you think about something that's producing data onto a smart contract, for example. So that's not what we intend to do. So from the Streamr network, the data itself is not going to the blockchain, but how to ensure that the data that goes to the Streamr network is coming from a valid source, right? So the idea is that it usually comes directly from the source. Like you have a sensor, and that sensor has a gateway or maybe direct connection, and that can sign the data point as close to the source as possible and then produce it onto the network, which kind of makes it verifiable from that point on. Of course, if there's some gap between the source and the kind of signing, then there's a place for vulnerability. The more interesting question, I guess, is how to, if you think about sensors or IoT, how to verify that the readings from the sensor actually represent what's in the real world. Like here we have a temperature sensor right here, and what if I do this? The data will be signed. It will look absolutely correct, but someone's tampering with the sensor itself. So that's something that cannot be solved by cryptography, for example. Maybe we can have several sensors scattered around in an area, and if one gives funny readings like this, then perhaps we can deduce that something strange is going on with that sensor.
I guess one potential solution to that might be to use trusted hardware. So
yeah,
for example,
of course. Yeah. I guess the world is going that way so that we can actually sign the data points on trusted hardware and then, but again, even if the hardware is trusted, how do we know that the environment is not being tampered with? There's no way to know.
Does anyone have any questions?
Hi, I'll have questions. So you say for example, you have a few sensors, right? How you can combine the data and and decide how do you use the data from multiple sources for the simple purpose? Let's say you have the sensors in the garden or in the field, for example, right? That might use the temperature or the sunlight, for example. Yeah. Yeah. And also the second question is about did you consider decoupling the key of the node for the establishing the connection and the key that actually sign the data, because you still can transfer it through the tunnel instead of using the same key, so that it will increase the security.
Okay.
And so third is what the partition, who decide how many partition to have, because we did not have that question yet.
Okay. I'm not sure if I will be able to remember 3 questions. So remind me, please, after I answer the first one. The first one was how to combine data from different data streams. Yeah, that's a fair question because the network transfers the data raw. It doesn't apply any processing to the data. That's on a layer on top. So you could have an application that does some data ingestion from the network, Today, those applications would be centralized, running on your server box somewhere, but maybe in the future they can run in a containerized, decentralized service, such as Golem, for example. Today, the easiest way to prototype things is within our engine and editor environment, which is like a visual programming-based environment where you can basically drag and drop some functionality. For example, take 2 data streams, then apply some processing like a moving average or whatever, maybe do some triggers, send you an email when your garden is drying out or whatever. So now this is possible. Of course, as in your own application, it runs on centralized servers and so on. But you know, if the computation or running the that kind of applications can be decentralized at some point, then we'd have like a huge stack of decentralized layers that can be used for running any application. So that would be very cool. The second question was about, can the key for identity and signing be decoupled? Sure, why not? But I think the convenience of using one key pair is one thing. Perhaps the only thing we need to establish is the binding between those two, right? So that could maybe be on the blockchain, and then we'd know, right? And the third question,
Like, how to decide the number of partitions and who decide that?
Yeah, that's a great question. I mean, I wish we can make some kind of auto-scaling happen there eventually. Of course, the smart contract won't do anything like spontaneously, but maybe there can be a function that can be called, and maybe there's a reward for someone who calls it at a time when the number of partitions will be changed. So this way we can incentivize that as well. But in the beginning, the number of partitions will be shaken from here, and then that's it. So we can have like reasonable. It doesn't matter very much what the number of partitions is. It mainly relates to the possible number of nodes in the network, right? And there's overlap, of course. Many nodes can be, like one node can be responsible for many partitions, or there are many nodes that are responsible for a partition because we have redundancy going on in there. So we can set it to a large but nice number in the beginning, and then when the network overgrows that number, it needs to be changed.
Thank you very much.
You've got a question over here.
Hi, thanks for making our streams come true. But what I was just out of curiosity is what's the uplift you get from sharding versus no-sharding? And given all the operations, how much does the Ethereum bottleneck affect like the life cycle of operations?
Okay, so why do we do sharding, and how does the Ethereum bottleneck?
No, do you have like any metrics like increase in transactions per seconds of using your sharded implementation? And even if it's off-chain, the bottleneck is still on-chain. So like what improvements?
Yeah, but it's really not, because, okay, so for the data transport itself, the scalability is near linear. So if one node can process 10,000 data points per second, then 2 nodes can process 20,000 and so on. So there's minimal overhead for adding more nodes to the network. We don't know where the limit is yet. It's something that's very hard to test in a lab, because the actual conditions for the network would be hundreds or thousands of nodes scattered globally in the peer-to-peer network. So it'll be hard to test things at scale, obviously. But the point is that there's minimal dependence between the nodes, and that should lead to quite effortless scalability. Now, why does the blockchain scalability, why doesn't it slow down the network, right? Yeah, the nodes need to report proofs every now and then, right? And that does set, let's say the Streamr network would now explode in popularity and there would be 500,000 nodes in the network, and all of them would want to every now and then report some proofs to the smart contract to earn rewards. Yeah, that does impose a problem at some point. But we can have configurable kind of reporting intervals, right? If we had more scalability in the blockchain, we could have more fine-grained things happening in the kind of incentivization mechanism. But if we don't have scalability, we just need to use a more coarse-grained approach, like nodes report something back to the blockchain like once per day. Then we get one transaction per day per node on the blockchain, which might be manageable depending on the number of nodes. If we had more scalability, we could report every 5 minutes, right? That would be okay. But maybe like once we have Plasma or some other means of side chain scalability, that will be possible. The Streamr network kind of incentivization can run in a side or child chain, and again, every now and then we report the state of the child chain to the main chain and verify it like that.
So one question I have is also, so one of the interesting questions in computer science in general around this kind of area of trading data for money is this idea of fair exchange. How do you atomically exchange this data and the money in one kind of atomic transaction?
No, we don't. So the idea is to have data licenses which are implemented as smart contracts. So we don't do an exchange of data point for money. That would be kind of microtransaction. That would also sometimes not be a good deal. I mean, I'll sell you one data point per £1, right? We make this deal. So far, I've been producing one data point per day, so you expect to be paying £1 per day. Then I suddenly start producing a little bit more data. Suddenly, you need to pay me £100,000. But sure.
But what happens if, for example, I subscribe to a stream and there's no data coming out of that stream because maybe that stream, I put up a fake stream, for example. Is there some kind of, for example, crypto-economic incentivization system or some kind of reputation system?
Yeah. So there's a reputation system, or will be, on the marketplace. Perhaps the data sellers can place a stake, which they lose if the data quality somehow drops or people file complaints. Of course, the problem there is always the dispute resolution. So if someone's not happy, who gets to decide whether the seller loses the stake or not? So we're thinking about this stuff, and we don't have all the answers yet. I think it can be made to work.
Exciting stuff.
Cool. Thank you.
Hi, Henri. Thanks a lot for your talk. One of the most important things in your concept is to being integrated with different sensors. How are you working with any manufacturers? Are you able to tell us a bit about that process? Have you started kind of conversations with any partners? How is it going so far, and where you see that going?
Yeah, so that's an interesting point. I mean, basically anyone who owns a device, usually the data goes from the device to maybe the manufacturer's cloud. They want to silo the data. You could make the integration between the silo and Streamr, but not everyone will do that. The obviously better choice would be if the device manufacturer made some effort, right, and made it easy for the device owner to integrate data onto Streamr. Let's say you have an IoT device, maybe you have a smart watch or something, maybe you could just flip a switch to have your personal data go onto Streamr, made available, anonymized or not. So yes, we are. We've been, for example, working with a group called Ruvi, There are some materials online about that. They have this cool Bluetooth low energy cookie, which is battery powered. It can measure temperature, humidity, air pressure, acceleration, if I remember correctly. And the cool thing about Ruvi is also that both the software and the hardware are open source. So it kind of fits the ideological framework of crypto and blockchain projects as well. So we are researching this topic with them on how to enable easy connectivity from IoT devices to the Streamr network. And there will be demos and that kind of stuff coming soon as well.
And since I've still got a microphone, I've been following you for some time. Cool. I do like the project. I know you've got quite a few people already using the engine and building stuff on it. Can you tell us a bit about your user base? Who are the developers? Like, are these some kind of companies? What kind of companies are using your software at the moment?
So we have around 9,000 users on the engine and editor platform. We don't know most of them, obviously. We don't spy on what they're building. Actually, there was recently this research we made, maybe Shiv can talk about that, where we interviewed not users of the platform necessarily, but our token holders, and found out some feedback from the community, which is interesting. Maybe we'll post some findings about that later on. Who are the users? The user base grew quite rapidly around like late last year, and during the ICO, people were interested in the project, came pouring in. Now with the market going a bit slowly, of course, the kind of general enthusiasm towards everything is a bit slower. But yeah, I think people are approaching us with questions. How does this work? Of course, the productization part is still very early. We've now been focusing on the marketplace, and the kind of engine and editor side has been on a like lower priority at the moment. But we'll do a major pass on that once we get there. So the marketplace should be out in the next 3 months. So that will be very cool.
Thank you.
Okay, last question.
Okay, I'm just trying to find out the scalability of your entire system, because I want a system that deals with...
Sorry, I'm not hearing you.
Hi, can you hear now?
Yeah.
Yeah, so I want to find out about the scalability of your system. I'm looking for a system with 130,000 nodes dealing with 40 terabytes a day. So what sort of, if I say to you, well, how will your system cope with something like that? Where do the numbers stack up?
Sure.
Oh, and it's about $60 million as well, but,
Yeah.
It's not mine, thank God.
Yeah. Obviously, one thing to become a consideration at some point when the data volumes go up is the bandwidth of available connections, right? So that kind of data and amounts of data, like 40 terabytes a day, you don't transfer that over a 4G connection, right? So, okay, that leads to a kind of deeper set of questions. Who runs Streamr? Does it run on data centers that have idle capacity? Does it run on people's laptops or mobile phones? I think in data centers, because the nodes and the network, they benefit from stable connectivity. They also benefit from having a lot of bandwidth, having a lot of storage to contribute. So these nodes that are stable and have a lot of resources should get more reputation in the network and be assigned more responsibility in the network as well. So it can be like self-adjusting. So if we have robust nodes in the network, there's no reason why even large data amounts couldn't be transferred there. But of course, there is limitations.
Always are. one data center disappearing because of an earthquake, another getting burnt down.
Yeah.
Minor details.
That happens, but that's why we have decentralization
Exactly.
coming. So.
Okay, let's give Henri a round of applause.
Thank you very much. Thanks for having me. Looking forward to beer after this.
Thank you very much, Henri. A few things that I wanted to mention was that we're always looking for sponsors at this meetup. We are self-funded. We're having to ask our speakers. We've got some great speakers coming up to kind of sponsor everything for us. But if anyone knows a great company that will benefit from the community, we are currently looking for a sponsor. So if anyone knows anyone, please come to me. I'd love to talk to them.